So this is not exactly tropical extratropical interactions, but it is related to predictions. You remember we defined something called Mjo diversity, where we had strong MJOs, weak MJOs, those that got stalled on the Indian side in the eastern Indian Ocean. Those couldn't cross, those could cross but got weakened, and then those that got detoured, and so on and so forth. So Bin Wang followed the analogy of El Nino, where we have so-called El Nino diversity, and he defined MJO diversity. So we will look at one model which has explored the prediction skill based on these MJO diversity spectrum. This is a good way to start. This is from this paper which is showing phase space diagram of the RMM index. We've been looking at showing daily phase, quadrant, and magnitude distance from the center of the MJO from 1st June 1974 through 31 March 2014. They are basically, this paper reports some climatological aspects of MJOs. I want to use this figure. Basically, we are going to talk about strong MJOs and weak MJOs. So here are the phases: Western Hemisphere and Africa, Western Indian Ocean, where we start, go into the Indian Ocean, Maritime Continent, Western Pacific, and back. Basically, when you are within this, why am I saying so many times basically? I'm not sure. Within this unit circle of RMM, so here we have RMM1, RMM2, 0 to -4, 0 to 4 on both axes. The MJO is weak, right? So, or inactive. So this is called the inactive region. This is called the active region. This is called the very active region, and this is extremely active region. So based on the magnitude of RMM1, RMM2, the trajectories which always go counterclockwise from phase 1 to through 8, and they can start anywhere, of course. There's a chopper going by making a lot of noise. So you would expect that the signal to noise of the MJO is going to be very different based on how weak or how strong it is. So that's one of the points that will come out of this paper that just appeared in BAMS. I think it's in press. I got the preprint. So it is showing, it's a GFDL model called SPEAR, which is specifically designed for MJO, or at least frame set up here for MJO forecasts, and they did forecast experiments by initializing and targeting weak and strong cases and so on. And it is looking at the bivariate correlation here. So the bivariate ACC for initially strong and initially weak MJO cases. In B, ACC as a function of, in B, ACC as a function of initial phases on the x-axis and forecast lead days, and bivariate ACC for strong and weak target MJOs. So what are we doing here? We are looking at each phase of the MJO and the skill seen as the bivariate correlation with lead time. So this is for all MJOs. When you initialize in a strong MJO for forecasting a strong MJO. So these are model experiments where you are just picking these and then also comparing to observations. You can see that the strong MJO starts with a higher skill and then drops off in about 6 pentads and remains slightly higher in skill than the initially weak MJO. As we said, the models have easier time capturing strong modes with strong signal to noise ratio. And you can see here initially strong cases, the lead time skill also, you can think of it as staying above 0.5 being skillful. So you can see that there is a phase dependence for both strong, for the strong case. So the lead time at which the skill drops off is not clear phase-wise here, but it's clear phase-wise here. So some phases have stronger, longer lead time skills. So it not only matters where you are in this phase diagram, but where the MJO started and whether it's strong or weak. Some phases have longer lead time. As we said, MJOs have waves, there is a background flow, there is wave Doppler shift because of the background state, and so on. There are tropical, extratropical interactions where the convection gets energized by perturbations, and so on and so forth. All kinds of details matter, not only for why the MJO is strong in the first case, but also at what longitudinal position it is in its life cycle, or where it is getting initiated. On the other hand, if you want to make a forecast targeting a lead, a strong case, then you want to go back in time and see at what lag days the forecast will have meaningful skill and in what phase. So here you can see that when the target is strong, the lead forecast seems to be again about 6 or 7 pentads for correlation skill above 0.5, which means that if you're targeting an MJO that is going to become strong, the forecast will be skillful from for lead time of 6 pentads, whereas if it's a weak MJO, then you cannot get good skill if you start way early. So longer lead times do not produce any skillful forecast. Only when you get to 2 pentads, you seem to get skillful forecast for a weak MJO forecast. Okay, I hope you understand what how these are different. So you can see the forecast lag days here as well, phase dependent. So depending on for strong target cases, there is higher longer lead time here, so it persists, the skill persists into other phases, whereas if you start here, the skill doesn't persist. Or if you start let's say at 8 pentads, then the skill doesn't exist. So the initialization has to be done in these pentads, whereas this in this phase it has skill from this pentad, and so on. So why do we care? Because you want to be able to look at teleconnections of each flavor of MJO. Okay, so here are standing cases, which they had 12, slow cases, jumping cases where there is a jump across the maritime continent. So this is standing on the Indian Ocean side and basically has no structure on the Western Pacific side over the maritime continent. In the slow case, it comes in as strong and then slows down across. And in the jumping case, it seems to disappear over the maritime continent and reappears here. In the fast scale, it seems to be coherent across. Okay, so again, if you look at lead times and skills, the standing one, the skill drops off very quickly in about 4 pentads, whereas the jumping one lasts longer. But for the slow and fast ones, the lead time, the skill is higher, but the lead time is similar to the jumping one here, and the fast one has the highest skill for the longest lead times. Okay, this is potential predictability, where you do model experiments and you find models, fast, slow, jumping, standing MJOs, and you try to target them as for forecasting, and theoretically all of them should have very similar forecast skill and lead times. Strong one maybe has a little bit stronger skill, but in the end it fades off with similar lead times of 8 pentads. So these are important basically because you want to understand these in an engineering sense and have confidence in your forecasts based on which flavor of MJO it is. So there is a process understanding that is needed as to why MJO has different flavors, and then there is the forecast side where you just want to exploit the prediction skills of the different flavors of MJOs in different phases. These also have relations to Enso and QBO. If you remember, QBO is a low latitude upper atmosphere process which has easterly westerly phases at quasi-biennial timescales of 28 months, has systematic propagation down, and they impact MJO. So we are looking at the Enso impact in SST and OLR and the QBO in terms of zonal winds at 50 hectopascals. So regulation of Enso and stratospheric QBO on MJO diversity. Observed interannual SST anomalies and OLR between day minus 15 and plus 15. In here we are looking at observed interannual 50 hectopascal zonal wind anomalies between day minus 15 and day plus 15. MJO type is indicated here. The black stippling denotes the regions where there is 90% confidence level in SSTs and these wind anomalies. Okay, so you can see the La Nina pattern here for the standing MJO, which gets stuck over here. For the jumping one, there seems to be a central Pacific El Nino type with cold SSTs here, but warm SSTs on this side. For the slow one, there is maybe a little bit of a warming here, but mostly a coastal cooling pattern. And for the fast one, the Indian Ocean is generally warm, and you have an El Nino that is central Pacific, but there is no cooling in the eastern Pacific. And similarly for QBO, you have different easterly and westerly zonal wind patterns that end up regulating. So in the jumping one, there is very little QBO signature in the upper level winds, whereas the slow one, standing one, have very strong westerlies and easterly anomalies. And for the fast one, there is a weak signal in mostly south of the equator in the SPCZ region, or where the MJOs get detoured, for example. So one has to see if the so-called fast ones are also the ones that are getting detoured. Actually they are not, because the fast ones here averaged around the equator are giving us 10 south 10 north, are giving us a good signal in the tropics themselves. This is finally the point, the observed teleconnection patterns. So observed and predicted teleconnection patterns associated with the 4 times of MJOs, and I won't worry about the skills in terms of correlations, but obviously the skill is dependent on which flavor of MJO it is, and you want to exploit that. But the point also is that the flavor of MJO is important, and we care about them because they have different teleconnection patterns. So ultimately, just predicting RMM1, RMM2 and MJO phases is not important unless you can accurately predict the teleconnections associated with them. So you are again looking at standing, jumping, slow and fast MJOs and teleconnections over the northern mid-latitudes to high latitudes. You can see that this one has decent correlation here. This one has a nice high correlation. This one has basically very little correlation when it is a slow flavor of MJO, and the fast one has a high correlation in the central eastern US and maybe over parts of Europe. So these are why we worry about forecast, because then these skills can be extended to other applications that we looked at in the S2S application course, where you can apply these to heat waves, snowstorms, cold waves, all sorts of other health and so on, based on how the MJO related temperature and precipitation anomalies relate to other things. So forecast is always about how it affects anything on land where we live. If El Nino and MJO happen in the ocean and they do nothing on land, then probably we wouldn't care so much, other than maybe for shipping traffic and so on. Okay.